Hey there, this is Dr. Rishi from the Learners Academy, and today we are going to talk about indices. This is a very interesting topic and is used a lot in the higher studies. However, it is taught at the 8th and 9th level for all the three boards, that is State Board, CBSE and ICSE. Though this topic is important, since it is taught at an earlier age, many students from 9th and 10th do forget it, and then when this topic is or the formulas that are taught in this topic are used in association with other topics, things might get slightly difficult for the students. So this is a revision video where we would be doing revision on the topic called indices or exponents. In some books it's written as exponents, in some books it is written as indices. Indices is plural for index. So when we use the word in its singular form, we'll use it as index, and when we will use it in its plural form, we'll call them indices or exponents. So let us understand what exponents are. Now if I take a number, say I take a number and I take a number 2 and I multiply it by itself, then this can also be written as a 2 to the power of 2. So writing numbers in this format is called as writing them in the index format, where this power or the exponent is called as the index. So any number we take, and if we keep on multiplying it with itself, we will get the index form, or we will get index of that number raised to a particular power. So I can have it as 2 multiplied by 2 multiplied by 2, since 2 is multiplied 3 times, so I will end up getting it as 2 to the power of 3. If I multiply it 4 times, then I will get it as 2 to the power of 4, so on and so forth. Now this was what happens after we multiply it by itself. What if the number is not multiplied by itself? If the number is just itself, then what would be the index? It's a very crucial thing to know. So any number 2, say suppose in this case, will always be written as 2 to the power of 1. So the index of just the number itself is 1. If the number is multiplied by itself twice, the index would become 2. If the number is multiplied by itself 3 times, the index would become 3. Okay. Now what happens when the index is 0? This is something very crucial again to remember. It needs to be remembered throughout your educational journey, because in many places where we have reasoning and logic, mathematical reasoning and logic, we do end up having 2 to the power of 0 or 5 to the power of 0 or 10 to the power of 0, and you need to know what that would be. So if I have 2 to the power of 0, it would be equal to 1. Okay, so any number to the power of 0, or if exponent of any number is equal to 0, then it would be equal to 1. Now just now we discussed what would happen if the indices are positive or 0. Now what happens if the index is negative? So again, let us try and understand this as well. So if I have 2 to the power of minus 1, it would effectively mean that it is 1 upon 2 to the power of 1. So every time we write an index whose index is, we write a number whose so every time we write a number whose index is negative, basically we would write that number on the denominator side, and this negative index would become positive. So same way, 2 to the power of minus 2 can be written as 1 upon 2 to the power of 2. And we can keep on repeating it for minus 3, minus 4, minus 5, so on and so forth. So we have discussed what indices are, we have discussed how to represent them, we have discussed what they would mean, we have also discussed what happens when the index is 0 and what happens when the index is negative. Now let us go ahead and study some rules that are associated with indices. Indices, as discussed earlier, indices can be positive, negative or 0. Indices can also be fractions. However, we will be discussing about it after we study the basic rules of indices. So let us first talk about the basic rules or the basic laws that govern indices. There are three basic laws that govern indices: the product law, the quotient law and the power law. So let us first write them each one by one and solve an example on them, so that we can get a brief idea about what these laws are. So the first law is the product law. So before we go and discuss about product law, let us briefly understand the terminology that we are going to use. So if I have any number a and it is raised to the power b, then this b we will call it as the index, and this a we will call it as the base. So base and index, these are the two things that we need to keep in our mind. Now let's go ahead and check out what these product laws are. Now I've discussed the terminology before I started the law because I am going to use this terminology throughout the video. Product law can be utilized when we are multiplying two numbers whose bases are same. Something very important. The thumb rule is the bases need to be same. So if I have a to the power of m multiplied by a to the power of n, then the product would be a to the power of m plus n. So basically the indices get added. Does make sense? Because let's take a simple example, say 2 to the power of 3 multiplied by 2 to the power of 4. So let's break it down to the simplest form. 2 to the power of 3 would be 2 multiplied by 2 multiplied by 2, and 2 to the power of 4 would be 2 multiplied by 2 multiplied by 2 multiplied by 2. So 3 here and 4 here. So this is written 3 times and this is written 4 times. So if we have to write the index of both of them, then we have to count how many times 2 is repeated. So effectively it is repeated by 1, 2, 3, 4, 5, 6 and 7 times. So it would be 2 to the power of 7. Okay. So whenever we are dealing with index, the product rule dictates that if the bases are same, then we will just add the indices of each of them and we'll get the final answer. Now this was a simple case where we had one of the index to be positive, one of them to be both of them to be positive. Now what happens if one of them is positive and the other one is negative? Okay, let us quickly see it. So let us say 3 to the power of 5 multiplied by 3 to the power of minus 3. So effectively this would mean 3 is multiplying itself 5 times. So this basically means 3 is multiplying itself 5 times, and then we would be multiplying it by 1 upon 3 times. So when we do this multiplication, it would effectively be 3 written 5 times, or 3 multiplied 5 times and then divided by 3 times. I can cancel them out, and what I would be left with is 3 to the power of 2, which effectively would be 3 to the power of 5 plus minus 3. So that is 3 to the power of 5 minus 3, so that is 3 to the power of 2. So we have seen what happens in indices if we are multiplying them and if the index is positive or it is negative. Okay, now let's go ahead and let us talk about the next rule that is there, that is the quotient rule. Now let us go ahead with quotient rule. The quotient rule tells the quotient rule is also applicable only when the bases are same. So if we have two numbers, two same numbers and they're raised to different powers, say a to the power of m divided by a to the power of n, then we would basically do the division, or we'd basically do the subtraction of, so we would basically do the subtraction of the indices. Now this is slightly complicated to understand because since we are taking a subtraction here, we need to understand which one of them is greater and how this rule would work if n would be greater than m. So let us see how it works with the different examples. So let us start with the example where m is greater than n. Then we would get, so say suppose we have 2 to the power of 3 divided by 2 to the power of 2. It would mean 2 to the power of 3 minus 2, so that would be 2 to the power of 1 or just 2. If we do it in the elaborate manner, we'll get it as 2 to the power 2 multiplied by 2 multiplied by 2 divided by 2 multiplied by 2, or it would effectively mean 2 multiplied by 2 multiplied by 2 divided by 2 multiplied by 2. These would get cancelled out and we would be left with only 2, which would be our final answer, which we also got using our formula. So this was the first case where m was greater than n, or the index of the numerator was greater than the index of the denominator. Now let us see what happens if we do it the other way around. Now we are considering m and n both positive, both are positive integers, and n is greater than m. So let's say we have 3 to the power of 2 divided by 3 to the power of 5. So the law tells us that it would be 3 to the power of 2 minus 5, so that is 3 to the power of minus 3, or that would be 1 upon 3 to the power of 3. Okay, now let's go ahead and see what happens if we do it in the elaborate form. So it is 3 multiplied by 3 divided by 3 multiplied by 3 multiplied by 3 multiplied by 3 multiplied by 3, written 5 times. So it would be equal to 3 multiplied by 3 upon 3 multiplied by 3 multiplied by 3 multiplied by 3 multiplied by 3, giving me, when I cancel these out, I end up with 1 upon 3 multiplied by 3 multiplied by 3, or 1 upon 3 to the power of 3, which I also got using my formula. So in the first case we saw what happens when both the numbers are positive and m is greater than n. In the second case we saw both the numbers, both the indices are positive and m is smaller than n. Now let's see what happens when n is a negative integer, or either one of them is a negative integer. So we first will consider when n is negative and then we'll consider when m is negative. What would happen when we do the division? Now let us consider an example where m is a positive integer and n is a negative integer, and we'll see what happens. So if I have say 3 to the power of 5 divided by 3 to the power of minus 2. So by my formula it should be 3 to the power of 5 minus minus 2, so that is 3 to the power of 5 plus 2, so that is 3 to the power of 7. If we get the elaborate form, we'll have it as 3 multiplied by 3 multiplied by 3 multiplied by 3 multiplied by 3, 5 times divided by 1 upon 3 multiplied by 3. So what would be the final answer? Since I'm dividing the given number by a fraction, I'll have to multiply by its reciprocal, giving me 3 multiplied by 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 3. So totally adding up to 3 to the power of 7. That we got initially in the formula, when we did it using the formula. Okay. Now let's go ahead one more step and let us check out about indices when both the indices are negative. Yes. Now there are two scenarios that we can get. Both the indices are negative and m is smaller than n, and both the indices are negative and n is greater than m. So let's see both the conditions and let's see what happens. Okay. Now let us consider an example, 5 to the power of minus 2 divided by 5 to the power of minus 4. So here the denominator is the index of the denominator is smaller than the index of the numerator. Now let's see what happens. So by formula it tells me it should be 5 to the power of minus 2 minus 4. So that would be 5 to the power of minus 2 plus 4. So that is 5 to the power of 2, which would be our final answer. Now let's elaborate it and see what we get. So this would be 1 upon 5 multiplied by 5 divided by 1 upon 5 multiplied by 5 multiplied by 5 multiplied by 5. Now since we are dividing it, what we'll do is we'll multiply it by the reciprocal. So we'll end up with the final answer as 1 upon 5 multiplied by 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 5 upon 1. So when we multiply it out, the final answer should be 5 multiplied by 5, 5 multiplied by 5 multiplied by 5 multiplied by 5 divided by 5 multiplied by 5. These two 5's cancelling each other out, giving me the final answer as 5 to the power of 2, which I got using my formula. Now let's go ahead and let us check what happens when the numerator is smaller, the index of the numerator is smaller than the index of the denominator. Yeah. So now we have, let's have say 7 to the power of 3, 7 to the power of minus 3 divided by 7 to the power of minus 2. So by rule we can write it as 7 to the power of minus 3 minus minus 2. So that would be 7 to the power of minus 3 plus 2. So that is 7 to the power of minus 1, or it would be equal to 1 upon 7. Let's see what happens when we do the actual division. So we have 1 upon 7 multiplied by 7 multiplied by 7 divided by 1 upon 7 multiplied by 7, giving me 1 upon 7 multiplied by 7 multiplied by 7. The whole thing gets multiplied by 7 upon 7 times divided by 1. So I've taken the reciprocal of the denominator because it's a fraction, giving me 7 times 7 upon 7 multiplied by 7 multiplied by 7. 2 of the 7's get cancelled out and I am left with 1 upon 7, which is my actual answer that I got from my formula. So what have we seen here basically is that what happens with the two formulas that we have there, and no matter what my m or n ka value is, my final answer would still hold good if I follow maths correctly. Now let us go ahead and talk about the third law that we use when we are dealing with indices. This is called as the power law. It is a very easy law as compared to the quotient law or even the product law for that matter. So if I have a to the power of m and then this whole thing is to the power of n, then it would mean that it is a to the power of m multiplied by n. It's a pretty simple, straightforward law. Now let's take few examples on it. The values of m and n can be positive, negative or 0. If it's 0, then the final answer is, even one of them is 0, then the final answer would be equal to 1. Okay, so let's see what happens when it is negative and when it is positive. If If one of m or n is negative, then obviously the final answer would be negative. So we would get it as 1 upon a to the power of something. Okay. Let us take a simple example where we have 2 to the power of 3 to the power of 2. Our law tells us that it is 2 to the power of 3 multiplied by 2. So it would be 2 to the power of 6. Now what happens when we do it in the elaborate manner? It would be 2 multiplied by 2 multiplied by 2 to the power of 2. Which basically means that this whole section is repeated twice. So we can write it as 2 multiplied by 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 2. This is once, this is the second time, giving me the final answer as 2 to the power of 6. So even if one of the numbers was negative, this would have become minus 6, 2 to the power of minus 6, and we would have written it as 1 upon 2 to the power of 6. So that friends was the basics of exponents. We would have one more video uploaded soon which would deal with the next part, the second part of exponents, wherein we would be dealing with exponents when the bases are not same. If you found this video helpful, please like it, do subscribe to our channel, and do share it with your friends. We are trying to make maths easy. This is Dr. Rishi from the Learners Academy. Thank you.